Oh my god, what have I done? Alright, this is a little better. Hi everyone. So the work for this devlog was probably the most difficult so far. From a high level, it may not seem that hard because what I really need to do is to move the hitbox of the sword in a similar trajectory as shown when we're animating. This is one of those things that are sort of easier said than done. I'll try to describe the complexity and how I solve the problem in a bit, but for now you can see that the swing animation includes the hitbox moving along with it. Now the hitbox is a little bit behind the swing animation. This is due to a couple factors. One is that it needs to come over the network, which doesn't take too much time, but it also needs to render, which isn't in the same rate as the server's tick rate is. So the tick rate in the server is 20 ticks per second, but it's rendering a bit quicker. So it's a close enough approximation, I would say, to get the job done for now. However, you will see a bit of a lag. But just keep in mind that on the server, it's actually a little bit tighter to what the animation is doing. Once I got things set up a bit, I ran into a few issues, as we can see with this clip, and another issue with this clip, where the orientation and the positioning of the hitbox wasn't correct. Okay, so to show the collision detection that it works with the sword now, I'll first make the two boxes collide, which I showed in the previous video. And you can see there's a collision between 6 and 4. And if you look here, this is the output from the server. So it's kind of flipping by quickly. Start, stop, 6 and 4. Okay. So one of these are 6, one of these are 4. We don't know yet, but we will soon. When we swing the sword, 7 and 4. So the sword is 7, and the other character is 4. The game simulation part isn't built yet, so it's not printing them in the correct order, but yeah, this is the collision detection in a nutshell. So before going into the design of the server, I thought it would be nice to look at a quick refresher, as it may be a bit helpful, some of the other concepts. So here we have a skeleton, and the skeleton is made up of bones. And what we want to do, and this is what was happening on the client, but we want to pass in a time and an animation, and we want to figure out the global transforms, we'll just call them GB2, the global transforms of each of the bones. And the global transform is essentially the position and orientation of the bone relative to the skeleton. And this is done by taking the local transforms of the bones. So it's local translation, local rotation, and local scale of each of these bones and multiplying them through this hierarchy. So in this case, it may go up to the spine from the root and over to this right arm bone, let's say. So again, this is the important part, and this happens, again, given a time and an animation. The time is important because you have some keyframes, let's say keyframe 1 and 2, and the time could fall in between or a little bit to either side of the keyframe, and this keyframe holds all of the samples for the bones, which then, again, you'll do this multiplication through the local transforms to get this global transform of a bone. So if you remember in the previous video, getting the sword in the player's hand was a matter of figuring out what this bone was and then multiplying it through the world transform of the player, which includes the position and the rotation of the player in world space. Okay, so now that we know that, before this update, this is a high level of how the client and server would communicate. So the client would give updates to the server, like, I don't know, we'll just call it a move forward. And the server would give back some animation. So this is usually like a U8 that gets converted into an enum that would decide, or would describe, excuse me, whether it was run or twerk, whatever the case. And then this would run back into this previous thing I showed, the skeleton, and it would generate those global transforms. So I'll just put bone n, and these transforms here would then get used in the renderer along with some weights to render the vertices. So we have the skeleton. I'll draw a little bigger. The skeleton, the mesh of it has some vertices. Each one of these vertices can have 4 weights, and these 4 weights would be multiplied by this specific bone transform, assuming it's this bone, right? The right arm bone transform, because each one has its own, right? The root and all that. So this is how it was used on the client, if that makes sense. Now, to describe the problem and why we needed a design change. So imagine we have the character, and the character, first off, has a bounding box. Actually, let me make this green. This might be a little more helpful. Has a bounding box, yeah. His bounding box moves along with the player's position and orientation, which is fine. That works great. However, the player now has a nice sword. And the sword also has a bounding box. So the issue is you cannot statically move these based on the position and orientation of the player. This needs to be animated, but remember, these collision boxes only live on the server. I mean, you can see them on the client because I'm sending over that data in a debug mode, but that actually isn't needed. So this hitbox needs to actually move, and perhaps along this path, right? So how do we do that? So this is the fundamental problem. So before, the client was doing the animation, which it still is, but the server needs to do it as well. So the first step is to pull out the component that was in the client. So if I have the client here, and I have I'll draw a little box for some component, and we'll call it some animator, or whatever the case. And the server didn't have this, so we need to pull this out into another library that the server can now use. I know these boxes aren't the same size. The size doesn't mean anything about the importance or anything like that. So now this animator can be used by both of these. And essentially, the server is doing the exact same thing that I showed before, which is it's going to calculate these global bone transforms, right? And the really tricky part about all this, which we'll dive into this piece in a second, the really tricky part about all this is this box needs to be animated, meaning it needs to figure out the transform, and we need to orient it and move it in a way that is following the trajectory of the animation, but also the physics engine needs to work out the collisions for the new positions of this box. So this is the fundamental point of this devlog. So now we're looking at the server, and if you remember, the server is already distributed. So one of the threads is the state fiddler. It's hard to write with this thing. The state fiddler, and this handles all of the player state and the inputs from the clients. And one way to solve this animation issue is to include that component here and run the animations whenever the user, let's say, triggers a swing animation. So then this will run the animation, and then it would send to the physics, if you remember this as well, the physics fiddler. It would then send the collision orientation and all of those updates it needs for the fiddler to, I'm drawing this in 2D, but this is the hitbox, to, let's say, move the box, reorient it, and also to send out collisions. Well, collision detections, not send out collisions. And this will go off to somewhere else. It's probably the gameplay fiddler or whatever I'm going to call it. I haven't worked on that yet, but that's coming soon. Okay, so this is generally how you could have handled it. However, the way that I did it was not this way. And one of the reasons for that is not only do we have the state fiddler, but we have the NPC fiddler. So I really didn't want to have to also run this animation here and then update the physics fiddler and all that good stuff. I thought it would be a bit better for scalability to run it this way. And not just scalability, but I think this is just easier to conceptualize. So what I did was I have this, I'll just call it A now, or maybe I'll call it AF for the animation fiddler. So what this does is the state fiddler and the NPC fiddler, they will register the animations and the bones. So why that's important is right now, I forget how many bones we have. We have quite a few. If I just wanted to register, let's say, the path to get the global transform for this bone, I could do that. I don't need all these other bones. However, I am just registering all the bones now for simplicity, but in the future, yeah, you can do it that way. So essentially, this will start up, it'll register the animations, and this animation fiddler, it has all of the skeletons in memory here, right? So you could have, I don't know, one skeleton, you could have the bowl skeleton, whatever the case. And it has a list of all the animations. So when an animation starts, again, let's say that the user sets up a swing, it will send the state fiddler, in this example, also the NPC, will send a request with, let's say, the ID, which is unique among all of the entities in the system. It will send an ID, maybe what animation it wants, and it will also send a list of bone types that it needs. In this case, there's only one, but it could be querying multiple of them. And then this will start the animation. And per tick, which is 20 ticks per second, it will send back that thing that we really need, which is the global transform of the bone. And really, this could be a list of those. And then this is interpreted on the state fiddler or the MPC fiddler, and then it goes to the physics pipeline. And the one interesting part is that instead of the player's box being set up and being static, the sword actually will register the hitbox, run the animation, which removes it, and then it will delete it after. And this is nice for projectiles. Anyways, so this is one fundamental difference, but basically this pipeline here is pretty much the same. It's just this part is added. So this was the solution from a very, very, very hand-wavy high level, but it seems to work fairly well. Anyways, thank you for watching. Take care.